Hello, welcome everyone. It is day 7 of Advent of Code, and that of course also means it's day 7 of Advent of Code in Kotlin. And I am once again back, just like the previous days, with a bunch of interesting things to do and talk about. I think it's gonna be great. I think we're gonna have a great hour or so talking about things. Now, if you ask me, today was quite a bit of a step up from yesterday, but I wanna really hear what people have to say. If our classic people who keep nagging about the tasks are too easy, maybe the opinions have changed by now. So, if you're in the chat, make sure you say hello and let us know what the problem looked like for you today. And the first comments we're already getting here. Today's AOC is pretty spicy. Okay, yeah. I'll be honest with you. When I read the description in the beginning, I was like, oh boy, this one's not gonna be a 5-minute solution. For this one's gonna cost me the morning. I think I ended up taking about like 40 minutes or so to solve both of them, which honestly I'm still pretty happy with, but yeah, it's not one of those things where you solve it and you go back to sleep after because you were just briefly awake. It's by that point you're wide awake for sure. Alexander says it was easy to implement and hard to debug. Took 2 hours to find the bug. Yeah, I feel that I really got lucky. I got a tiny little bug in my program where I got an empty output on one thing. I just got lucky and managed to fix it. Maya says, in retrospect, I wish I built it without a tree. We'll see. We'll discuss that. And I find that out. Hey everyone, it's nice to have all of you joining. So, I am excited for today. I just came back from a nice little walk. Got a little bit of fresh air to really, clear my mind and make sure that I can give this one the best that I can, and I don't need to leave anything out in the explanations. And I think it's gonna be good. Olaf, our resident, always harder wanting person, someone who always complains about the problems not being hard enough. Hey, at least a little bit, right? I'm sure it's just gonna be a few more days, Olaf, until even you start sweating. I hope. Maya asked, what kind of tea am I drinking? The tea that I'm drinking today is Christmas Bakery, and it tastes very much of like cinnamon and cookies, and it's just a delightful Christmassy experience. It honestly puts all of this together. If we didn't have the music and I didn't have my tea, I don't think we would have the same kind of nice and cozy evening feeling that I do now. Yeah, it wasn't hard, says Olaf. No catches. Yeah. Oh, it's fine. It's fine. Okay. Well, I think we've given everyone enough time to kind of appear. So let me make sure to remind you how you can the most easy get a couple of cool exclusive Kotlin swag things. And let me put that one up on the screen again here. We have the Advent of Code 2022 in Kotlin GitHub topic. If you add that one to your repository, we'll be able to find it real easy. And I'll be able to select a couple of random winners as long as you have attempted to solve at least 3 of the problems. And you have some kind of way of contacting you in your GitHub profile, because otherwise it's going to be hard to get these exclusive things to you. Now, the cool thing is, of course, you can, like I think Todd said the last time, you could just go back and code along with some of our earlier streams, or even with this stream, and get a couple of solutions that you can submit and upload. And that's perfectly fine, as long as you're, learning something for yourself. You don't have to be the fastest. You don't have to be the best. You just have to have fun. But today's guest is a little bit special in this regard, because they actually came around and just straight up won Advent of Code in Kotlin for 2021. So they placed on the very top of the community leaderboard, which is really interesting to me because I am slightly competing about that one as well. And so I'm curious, and I think it's going to be a couple of good discussions and answers going on here. So I'm just going to welcome Femiant to the stream. Hey, how are you?
Hello. I'm not sure if I'm showing up on the stream yet, but
you are.
Okay, there we go. I can see myself now. Yeah. So hi. I actually think it depends on how you count the wins last year, because I'm pretty sure like Roman would have beat me. If, yeah.
I think Roman doesn't count. I'm not sure. But in that case, if you want to see the real winner, make sure you tune in tomorrow, where we'll be joined by none other than Roman Yelizarov. Way to steal your own thunder.
Yeah.
Yeah. No. It's even if on a technicality you would be second place behind a literal ICPC legend, I think that's still something very much to be very proud of. So kind of, do you have a longer history with competitive programming or Advent of Code specifically?
No, well, competitive programming in general, no. Advent of Code I've been doing since, I think, 2017, the second year it was running. I didn't discover it until a few days into the second year, but I've been doing it every year since. It's just a pretty fun thing to do around December, because, there's downtime from work, at least, for me anyways. I know that's not true for everybody over the holiday season, but yeah, it's just a fun thing to do. You can spend time. I love, relative to other competitive, programming sort of challenges, Advent of Code is very free in allowing you to basically use any tools at your disposal. And of course, there's a ton of fun things in the community where we come up with ways to one-up each other, or just spend time optimizing things that don't really matter, but it's just enjoyable anyways.
Yeah, this is something that's I think really special. It's definitely part of my my daily routine in December to go on the Advent of Code subreddit and see what kind of crazy things people have done this time around. Whether they're, I don't know, running it on a fax machine or solving it in Excel or on a whiteboard. I feel like there's nothing that would really be unexpected from Advent of Coders. So you actually and I'm gonna show this one on stream, because when I checked out your repository earlier today, I realized that there's these wonderfully named folders here. I'm gonna make this a little larger, because so my repository has a source folder in it, and then there's a bunch of Kotlin programs, and yours on the top level starts with HSKT, PY, and RS, which I'm guessing is Haskell, Kotlin, Python, and Rust.
It is. If you scroll down to the README, you'll see sort of links to all of the solutions as I'm making them as well.
Oh, wow. Okay. Sweet. That's really... Okay, two things. First, that's really cool. Second, I always wanted to do Advent of Code in Rust as well. Third, For any particular reason?
Well, there's a few. So basically, when I started, I was working in Haskell because that's honestly a great language for sort of mathematical puzzles once you get your head around it. And after I left school, I did not get an opportunity to use it, even though I enjoyed it. And I started doing them in Kotlin as well, because for some puzzles that, being able to switch between imperative and other programming models really helps. And I do enjoy using Kotlin. So I did that. And then a few years ago, I was helping a friend learn programming and and they were getting started through Advent of Code as well. And so I was providing sort of Python solutions to compare against and show, what idiomatic code looks like. And Rust, I started, I think, just 1 or 2 years ago as this is my exercise for learning the language. So.
Okay. That's really cool. I think so. One of the languages where I used or where I tried a different language before for Advent of Code was the first few days, and I did them in OCaml because that's the functional language that we learned in university, which was all fun and games until working with their immutable data structures came to the point where I would write an algorithm. I would start running it in OCaml. I would switch to a different computer. I would write out the solution in Kotlin, run the solution. The solution would be done, and by that point, the other one would have stopped executing or was about to finish.
Yep.
Yeah. And since it felt wrong to use OCaml with like mutable data structures and arrays, I decided, I was like, okay, we're going back to Kotlin. Are there any languages that might join these ranks in the future? I'm curious.
For myself, I am considering Raku, which is formerly known as Perl 6.
Raku, okay. Okay.
Before sort of, one of the languages I learned on way back was Perl 5 or Perl 4, really kind of evolution of the same language. Mm-hmm. And from what I've seen of Raku, it's very intriguing. It's a very different language, but it tries to keep some of the aspects of Raku, or rather of Perl. And I don't know. I'd like to learn it and see how well it does, but I just have not put the time into it.
I understand. So we are almost ready to start with our dramatic reading, everyone's favorite. Got my hat right here. But I have one more question. So you managed to finish at least, no matter how you twist it and turn it, very, very high in the rankings. What's the secret sauce here?
Well, I think for this, part of it comes down to possibly having what I assume are similar interests to Eric, the creator of Advent of Code. So his puzzles use, in general, this one in particular is not that algorithmic, but the ones that are like, things that I might have seen before. Like, for example, we had some problems before that are like, this is a compression algorithm in disguise, or it's famous. He's really loves these virtual machine systems, and that's something that I've also had lots of fun doing. Like, I play around with different bytecodes and all of that as well. So that's part of it, but a lot of it is really just you get better after going through all of Advent of Code the previous years. Okay. It's between that and, I think it's mostly that. It's not something that if you look at my ranks on the global leaderboard, I've just been going down every year as more people are joining. Like I haven't been really getting a ton better, but it's just fun anyways.
Okay. Yeah. Well, we're definitely gonna have a section at the end where I'm gonna ask you your predictions, which now I'm gonna place an even higher weight onto because of the alignment with Eric's hobbies. To see what else we're coming here. I feel like the general consensus is that some kind of virtual machine is coming, but we'll save that one for later. Okay, so then it's time to dive into our problem statement for today. We'll have that one, and then you can walk us through a solution. Let's see here. Okay, gotta make sure I don't knock all my tea equipment over here, and get ready. Okay, great. Okay, it is time for day 7. No space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. System-update please pretty please with sugar on top. Error. No space left on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output, your puzzle input. So, for example, we get a CD, an ls, which lists directories and files, and we get a whole bunch of them. The file system consists of a tree of files, plain data, and directories, which can contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Within the terminal output, lines that begin with $sign are commands you executed, very much like some modern computers. CD means change directory. This changes which directory is the current directory, but the specific result depends on the argument. CDX moves in one level. It looks in the current directory for the directory named X and makes it the current directory. CD ... moves out one level. It finds the directory that contains the current directory, then makes that directory the current directory. CD/ switches the current directory to the outermost directory, /. ls means list. It prints out all of the files and directories immediately contained by the current directory. So 123 ABC means that the current directory contains a file named ABC with size 123. Dir XYZ means that the current directory contains a directory named XYZ. Given the commands and output in the example above, you can determine that the file system looks visually like this. Get a little bit of a tree with directories stacked inside the directories and files with sizes. Here, there are 4 directories. / the outermost directory, A and D, which are in / and E, which is an A. These directories also contain files of various sizes. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic size. The total sizes of the directories above can be found as follows. The total size of the directory E is 584 because it contains a single file, I, of size 584, and no other directories. Then the directory A has a total size of 94,853 because it contains files F, G, and HLST, which has plus a file I which is contained indirectly, because A contains E, which contains I. Then we still get directory D with another large total size. And then as the outermost directory, / contains every file, so it's the sum of the size of every file. To begin, find all of the directories with a total size of at most 100,000. Then calculate the sum of their total sizes. In the examples above, these directories are A and E. The sum of their total size is 95,437. As in this example, the process can count files more than once. Find all the directories with a total size of at most 100,000. What is the sum of the total sizes of those directories? Okay. Effeminat, what are we thinking here?
Yeah, so we are only given the terminal output. We can't actually drive the terminal ourselves, unfortunately. Yep. Which would have made this easier, but is a lot harder to, we're provided a, single static input. That's how Advent of Code works.
Mm-hmm.
So, yeah, the thing here is there is a tree structure that we need to reconstruct from this input that we're given. Yeah, so, as we work through it, we do have all of the information we need in the input because we know what our current working directory is at each point. You can check that everybody's input started with cd/. Mm-hmm. So it doesn't matter what your original, working directory is. You always start at / and you list and go on from there. And you can check that our input actually does list and go through every directory that exists exactly once. It's not something I actually checked when I was first running through this puzzle.
Yeah, but I certainly also didn't check this one. I was considering if having a list instead of a set at some point was gonna bite me, but luckily it didn't. Okay. So yeah, it sounds to me that we just need to go ahead and we need to somehow reconstruct this tree structure. Am I hearing that right?
Yes. Well, as you'll see in my solution, I actually cheated a little bit, and I don't actually create a tree.
Oh, okay.
But, yeah, there's a couple of different ways to approach this, and one of them is to actually rebuild the tree like you see here. Mm-hmm. And one of them is not.
Okay. Wonderful. So just before we move on, there's a couple of people saying there's a little bit of a beeping noise going on with you. Is there anything you could do about that? Or
a truck outside of my house, so I am apologize. I cannot do anything about it.
Okay, that's perfectly okay. Just making sure you're not, your noise canceling headphones aren't canceling out the fire alarm, and we're gonna see you go up in flames. That would be a shame. So okay. Great. Then let's have a look at your code here. You're also logged in with code with me, so we should be able to see your cursor if you mark anything, and then you can start us off here. I guess. Well, where do you want to start us off?
Well, so the way that my repository is set up, which we are looking at right now, I have every day has a entry point where it is given the input already split into lines. And so what the first thing I do is just to parse the input. And so here, I'm building up a map of all of the sizes of all of the directories. So that is what this map is. It is a map of string being the directory path to int, which is the total size within that directory. And so I am starting off with, oops, that's not what I wanted to, with the root directory, which I'm representing with an empty string here, it's a choice that I'm representing the paths after the slash. There's different options here. I actually flip-flopped back and forth on how to represent it a bit as well. You can see in my Git history that changed a few times, but I'm starting off with 0 just so that even if I get no input, my code later on doesn't crash.
That's good.
Then the current working directory, I also initialize. It doesn't matter what it is initialized to because the first instruction will initialize it. But then for each line, so here we see pattern, which if you scroll down to the bottom of the file,
scroll down here,
is a regex. And so you can see that just out of habit, I used a raw string, which means that you don't have to worry about doubling up backslashes when they appear. But it is unfortunately a little bit awkward when you have dollar signs in Kotlin in raw strings because you can't really do much about them. But so if you just put it in square brackets, it's not necessary here because the dollar sign can't do anything with a space next to it anyways, but it's just a habit. If you put a dollar sign in square brackets, it's always a literal dollar. So so I'm parsing out the cd commands and lines that start with numbers. And it turns out that's all we really care about. So
this is just to refresh on my regex basics here. You have a capture group here, which means you're just interested in whatever it comes after the CD and whatever your numbers are. Is that right?
Exactly. Yes, with an alternation between them. So either the left side of that matches, or the right side matches.
Okay, so it's either a command or it's a number, which I suppose, given our input file, that would be the file size of a file.
Exactly.
Okay.
Yeah. So originally I did capture the file names as well, but it turns out we don't actually need that, so I removed it.
Okay. Interesting.
Yeah.
I didn't know.
So basically here, we try to match the line. If we go back up to the top, we're matching a line. And if it didn't match, and because I'm not matching everything that's in the output, like the command for ls or the directories in the output, I'm not bothering to match because I could, but I don't need that data. So I'm not. So I'm just continuing the loop if they didn't match.
Oh.
And then match.groups1 is the first capture group. And if it's not null, then I know that the first part of the alternation is what the regex matched. So I can update the current working directory because that was a cd command. And if instead it was group 2 that exists, then it was the second part of the regex that matched. So I have a file size.
Oh, that's really elegant. I like this. So first of all, in groups, I believe the 0 is like the total string that matched the pattern.
Yes.
Is that right?
So yes, this is one of the. It makes sense that it's for consistency with almost everybody says the 0th group is the entire match.
Yeah.
If you look at other regex systems as well, but it does feel a little out of place when you're using bracketing and stuff where you expect the first index to be at index 0 almost all the time, but that's not the case for regex groups. So well, it is what it is.
Would group values help in this case?
So group values could work. They would be a little bit I think they'd be ambiguous here because they return empty, if I recall correct, when they're not matched.
Okay.
Instead of null. So.
Understood. Okay, so there's a good reason for the choice here as well. Understood. Okay. And okay, so this is just kind of your branching. And so what I'm seeing up here is that you set your current working directory on actually using pretty basic logic. I mean, if it's slash, you're just going back to the beginning. If it's ... then you're just gonna remove everything that's after a slash. So you're removing the current directory, kind of like popping it off. And then if in another case, if your current working directory is empty. Oh, so this, I guess, is because of your because you decided not to represent it with a leading slash. You
Exactly.
do this kind of change. Okay, I understand. Okay, and that just brings you into whatever directory we see.
It just simplifies the case above it, though, because, for example, here, if I'm in a directory called A, and I remove everything after the slash, well, there is no slash in the representation of A, but if it's missing a slash, then there's a missing delimiter value argument you can pass here, which says, well, if there was no slash, then go to an empty string.
Oh, so. I didn't even know that we had this missing delimiter. I'm learning something new. That's really cool. Wow, I'm excited. I love it. Cool. I'm gonna use that one all the time nowadays.
Yeah,
that's amazing. Okay, and then the alternative was changing in. So this one was a CD, yes?
Yep. And then this is handling C, and this is handling. We found a file size.
Yeah. Okay. And walk us through that one again real quick as well.
So what I'm doing is I'm starting with the current working directory, and there's a slightly awkward dance you have to do in Kotlin with nullability, but basically here I do get or else. What is the size that I have in this directory so far, or 0 if this directory wasn't in the map yet. And I want to add the current file size to it and put it back. And then this is, so this would be, it would be, you would write it as, say, you would like to write it like this, but it doesn't work because, this returns possibly null.
Okay. So, yeah.
I mean,
I guess you could go with an Elvis operator, but then you still get extra parentheses because you need to scope that one. So
yeah, you still need to put a plus size at the end of that also. So I just left it as it is, and then I move up to the parent directory and do the same thing again, unless I'm at the root. So basically, every time I hit a file, I add that file size to the current directory and every parent directory. So I don't need to build a tree.
Oh, that's really fun. That's really cool. So just kind of from if there's a really deeply nested file, then kind of all the folders or the directories that contain it, they all get incremented all the way up, including the root, I guess, right?
Yep.
Okay, so, and this is like if you hit the root, then you update this one, and once you are at the root, you get this. I see now why it might be a nice way to have this one as empty, represented as empty, because then you can just break out using an isEmpty. That's nice. Wow. Yeah. I'm liking this solution. This is good. Yeah. Was this kind of the first thought that came to mind when you did this?
It was more or less. So as I said, initially I was tracking file names. So my very first pass was building up a very similar map like this, but just with a map of all of the file names to their sizes, and then walking through every file in there and adding their sizes to a map of directory sizes like this is doing.
Okay.
But because that file map never got used, I just effectively inlined it into here.
Nice. That's it's a cool way of kind of doing the whole thing at once. Okay. And then we're of course not done yet, because this just gives you a tree or a list, I guess, of files.
It's kind of a flattened tree, right? It's if you ever possibly you would never do this, but if you ever tried implementing a file system with a database, right, with a regular, say, relational database or something, you end up with something that looks basically like this, right? You have everything in a big flat structure. So
okay. And then you can pretty much, because we remember that we just want to have the sum of those files that are smaller than 100,000, you pretty much write that out, literally.
Yeah, it reads very naturally here. Yeah,
that's really, exactly. That's pretty much all there is. There's no magic to that. I have to say, I'm very impressed that I can fit this solution on the screen like all at once at a hopefully even on-stream readable font. And apparently a couple of people in the chat agree that this might be even more comfortable to debug than some other solutions. Maya says these full paths would make debugging easier too, I think. And Jonathan also agrees his tree is horrible to debug if you do not have the whole directory structure.
Yeah, if you're in the middle of a tree and figuring out where to update, that is a pain. I also heard people in the Slack complaining that, they were running into Stack Overflow issues with printing out these trees because they were so deep.
Really?
So, yeah. I mean, if you use a normal data class, then its toString method calls toString on its members. And depending on how evil the input is, you have a very deep tree, which you can construct, but then toString will then be sort of just a cascade of calls. One for each level.
So you get some casual complexity just in your print statement, which is no good. Okay. Well, I think that's the first part checked off. So we're gonna quickly go for part 2, and then this one is much shorter. Very nice. And then you get to roast my solution. Because guess what I did? I built a tree. So that's a bit of a spoiler here.
I mean, it is a totally workable solution as well. So.
Yeah, I mean, I got there in the end, so it's all fine. All right, part 2. Now you're ready to choose a directory to delete. The total disk space available on the file system is 70 million. To run the update, you need unused space of at least 30 million. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of used space, is 48,381,165. This means that the size of the unused space must currently be 835, which isn't quite the 30 million required by the update. Therefore, the update still requires a directory with a total size of at least 8,381,165 to be deleted before it can run. This would be much easier if these had like thousands separators.
Would.
Yeah. Which is also why I did not decide to type any of these like numbers out. I just copied them. I was like, I do not trust myself.
Yep.
To achieve this, you have the following options. You can delete directory A, which would increase unused space by 584. Directory A, which would increase unused space by 94,853. Delete directory D, which would increase unused space by 24 million-ish. Delete directory / which would increase unused space by 48 million-ish.
Yeah, just kill everything.
Yeah, I mean, that's a rm-rf/. That's a classic for a system update. Directories E and A are both too small. Deleting them would not free up enough space. However, directories D and / are both big enough. Between these, choose the smallest, D, increasing unused space by 24 million-ish. 25 million-ish. Find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? Okay, so people who have paid attention will see that there's not that much code left in this file, so it can't be all that hard. So, Ephemian, do you want to tell us what's going on here?
I can totally describe what I've done here as well. So, we need to know how much disk space we need to free up. Mm-hmm. So, to know that, we need to know how much disk space we're currently using, which, thankfully, because of how we've calculated things, is just the size of the root directory. So we can just get that here. So I've done this instead of that, because that is nullable.
Yep.
Which, I could handle, but it's like I put a 0 in at the very beginning so that I would never have to worry about this.
Yeah, it's going to be fine.
Yep, exactly. So, yeah. So get value is basically just get, except it throws if the key is missing. So that's my total size. And this is actually an update that I put in today because I realized that, just like 3 hours ago, maybe I realized, oh yeah, I could do this better. So this is basically filtering, and instead of calculating the amount of space I need to free up, this is literally just saying, is the amount of space afterwards going to be greater than the target? So I found that easier to read, right? Basically, yeah. Total disk minus the amount that I'm using up, is it greater? And find the smallest one that will satisfy the. So.
And since you're using as sequence, you're also kind of, I guess, doing each filter individually and then I'm not sure if this one actually, does this one provide you any performance benefits here?
So I wrote it like this. I actually, if you switch branches, you can see I actually did benchmark this later on, and it was not noticeable.
Okay.
Whether I use as sequence or not.
I actually think I have the benchmarks here as well. We can take a brief look. Is this one? If you take a look at the screen share.
Yeah, unfortunately, my this is very much not annotated. But
okay.
Basically, I just started adding random numbers onto this. So basically, where it says 7C part 4 and part 5 are basically this solution versus the solution with a
with no sequence.
Right, exactly, with just a normal list.
Okay, so yeah, here we're seeing they're both around.
Like the difference is within the noise.
Yeah.
So it's definitely not something you can base any conclusions on.
Very much comparable. Okay, good to know. All right, yeah, and then you're just kind of getting the minimum out of that, and that's pretty much it.
Mm-hmm.
Very elegant, because you didn't have to adjust your data structures, didn't have to write any more algorithms. This is all foreshadowing. And yeah, you just end up with a very neat solution. I like this a lot. When I saw the problem statement, if you would have told me I can solve this in 35 lines of Kotlin code, I would have been very impressed. And sitting here, I'm still very impressed. This is a nice solution. Okay, so we're gonna switch over and take a look at my solution. Let me just see here. Just pull that one up. And I can walk us through that one. Hey, I can almost... I was going to say I can almost fit that one on screen, but yeah, that's not going to happen. Okay. So. Now, this one has a couple of stipulations and a couple of shortcuts and other parts where it's probably needlessly long. So I decided I was going to create some kind of like actual tree structure and then just go through recursively adding up elements. So the first thing I did was I looked at the test at the input case, and the very first thing was like, okay, how often does cd/ appear? That one appears only once in the beginning. So I was like, okay, that clearly just puts us on the main folder. So we just drop that one. We're just not gonna bother even interpreting what a slash does at all. And apart from that, I decided, okay, since everything that we do in here is either a command or a command and an output right after it, we're just gonna split on the $sign, which gives us either standalone commands in the case of cd, or it gives us multiple lines where the first one is the command and then everything afterwards is the data, like in the case of ls. Yeah. And then I just decided I needed to have some kind of tree structure. So I created this v folder. Don't ask me about the naming. The naming comes because I also created a file, and then IntelliJ really enjoyed auto-completing Java files. And I was like, okay, we're gonna prefix this one so that the autocomplete doesn't annoy me. And yeah, so the general gist for these are I save away their name, which not sure if that's actually necessary, but I wasn't sure what part 2 was gonna bring. And I save away the children they have, as well as the parent, because I need to be able to navigate up out of my tree as well. So I need to have the relationship in both directions. I need to know what am I containing and who am I contained by, or what am I contained by. And I also needed to somehow store the files which had an actual size. And since these share a couple of common properties, specifically that they have a name and that they are contained within a parent, well, potentially, I decided to model this as a sealed class of file system nodes. And with that, we could start parsing the input. I'm just keeping track of the current folder, just using a variable. I'm also making sure I don't lose track of the actual root, because I'm going to use that one later on to kind of traverse this whole place. And then I just go through and I look at each input, ignoring the first cd into slash, and looking at the first 2 characters, which are my commands that I need to look into. If it's an ls, if it's a directory listing, then we are just going to take whatever folder we have right now, and to its children, we're going to add everything that follows the command itself. This is the ls that we're getting rid of, as a directory listing. So here I have a little helper function that interprets a list of strings as directory listings, and also makes sure it can hook up the parent properly for these directory listings. This is a pretty direct one-to-one mapping. You take each string. If it starts with dir, then it itself is a folder or a directory. I'm not sure if this might be because I'm not a native English speaker. in German, we refer to file directories as folders, but I don't think anyone else does that. Yeah.
I think we use both of the terms in English, and it is pretty inconsistent. So.
Okay, all right.
Yeah.
I always felt very unprofessional when I said folder. So now that I realized I'm doing this on stream, I'm like, oh god, they're gonna judge me. Yeah. So if it is a directory, we're gonna get rid of that prefix and its space, and we're gonna create a new folder object, hooking it up to whatever is the parent, what is supposed to be the parent where this folder is contained in. And if the first thing that we're seeing is a digit, then we clearly have a listing for an actual file. So a file that where the first part is the size and the second part is the name. We do the same split operation, which I've been doing, I think, almost every day in Advent of Code so far. We create a v-file object just with the name and the size, and also hook it up to its parent. And if we're seeing anything else, then something went horribly wrong, so we're just throwing an error. Okay, so with that, we have the directory listing done. The change directory is actually somewhat easier. It's you just take the you can determine the path by removing the prefix, including the space, and seeing whether the path is ... which means we're going up. If for some reason your current folder does not have a parent, which means if you are most likely in the root directory already, then doing another ... would perform an illegal move, which isn't happening here. Otherwise, we need to find the file, or need to find the node that we are navigating into, which I just do a little bit of a search for the first one where the name is the same as the one that we have been requested. And since I'm using a CL class hierarchy, so since this one, I'm not sure if it's going to show me. Unfortunately, it doesn't do a substitution here. Since this is going to return me a node, I need to make sure that this is an actual folder. Otherwise, we would have tried to change directory into a file. That wouldn't work. Okay, and with that, we have all the input parsed. We have a tree, which is fine, and we can start finding folders in here. Specifically, I needed to find the folders with a maximum size of 100,000, and then sum them up to get the first solution. So I wrote a function in first of all an abstract function just for a node that can recursively get the file size for anything that's attached to a node. And the trivial implementation for this one is, of course, for a file. If you recursively try to add up all the things that are inside a file, it's just the size of the file itself. It's a little harder to do that in a folder, but not much harder, because a folder's size is just the sum of its children's file sizes. So this is kind of the main part of determining how your file size comes about. And the actual kind of like recursive algorithm, I guess, that we're using to find these folders is this one. So we're providing a maximum size, and this is going to return us a flat list of folders. So we're just looking for everything that's a folder, because we're not interested in files anymore. And we're going to go through recursively and find any other folders within those folders that still fulfill the max size. Now, this is what was described in the problem statement, as well as you might be counting the same file twice based on your directory structure. And based on whether you... And then you need to make a decision. You also need to apparently update writer. Always happens at the most convenient times. we need to make a decision. If the file size for ourselves, so for the current folder that we're looking at, fits our predicate, so is less than our maximum size, then we add it to our return value that we pass up recursively, and otherwise we kind of ignore ourselves. So we don't add ourselves, we only add whatever things are in the children.
Mm-hmm.
Yeah, and with that, you arrive at this little snippet here, which finds you the folders with a max size of 100,000, and from there, the rest is pretty easy as well. I did not trust my math very much, so I made this very literal, made sure the total disk space is my 70 million, used the little underscores that we have in Kotlin as syntactic sugar to make sure I can count all the zeros. The used space, just like in yours, is just kind of the file size of the root directory. The free space is whatever's left after we've removed the used space from the total disk space. We know how much we need, so we need to see how much we need to free up. And then at that point, I kind of recycled my initial function. This one was like, okay, I just need folders. I don't care how big they are. Just give me all of them. Give me the flat map. But please only give me those where they are big enough that if I delete them, they'll be above the freed up space. And of course, of those, I want to have the one that's the smallest. I realized that most likely there's a nicer way to do this one where I don't call my recursive get file size function twice, but I couldn't be bothered. Even though it would be a small refactoring. I was like,
I mean,
I was
it's
like
running in like milliseconds anyways.
Yeah.
So unless you are actually trying to optimize, it doesn't matter.
Exactly. I was at the point where it's like, I'm 40 minutes into this. I gotta submit. I gotta get this done quickly now. Yeah. And so that's kind of my solution, which is longer, but I think has its own kind of charm because it's this nice
I do
exercise.
think actually it's kind of interesting that the way we set up our structure kind of affected the choices we made as well. Like, you were actually able to split on $sign because you had the entire file as a single string to begin with. Whereas in my project, because I'm like, well, we split into lines every day. So I put that in the runner. So every day starts with all of the lines already split up, which means like this option is not as easy for me.
So does that mean that it kind of threw you a wrench in the works on day one as well? Because on day one, if people remember, we had numbers that were grouped by double spaces or by an empty line.
So I had a. Let me actually see what my code looked like on day one. I think
I forgot that we are also in your repository here, so we can just look at that.
So let's see. I think I just had a sort of imperative loop just going through, and basically every time you hit a empty line, which is when that is null, then I do some action based on that. So, but it was not as convenient as, just being able to split up into groups to begin with.
Yeah. But let's also talk a little bit about your repository setup. So I'm already inside the Kotlin subfolder here, but I'm seeing a lot of interesting stuff here. I'm seeing a Graal VM folder, which is exciting. I'm seeing the fact that these are split up into JVM main and native main, so we're doing some Kotlin multi-platform. I'm seeing something called a processor, and beforehand you told me you were doing some kind of compiler plugin stuff magic. So what's happening here?
So so this is a multi-platform project. So it is currently targeting JVM and basically your computer. So it is not targeting iOS. but it is targeting Mac if you're on a Mac, Linux if you're on Linux machine, etc. native. And it has benchmarks for them. So unfortunately, well, for better or for worse, IntelliJ doesn't work super great with KSP, which is what I'm using for generating the sources. But basically, you saw on each day, I have a @day annotation and a @day.part annotation.
Yes.
And so what that basically does is if you can just look for a file called main, it'll be in build generated KSP.
Just a file just called main.
Yeah, main.kt. And... no, it's possible that
I'm not sure.
it
So in
decided not
build,
to
you said generated KSP.
Yep,
Okay,
there.
this one.
So it is completely just auto-generated off of all of those annotations. So I add a new class, it gets added to here when I run with Gradle, and it's just like magic. So get input, I have to implement separately for JVM and native because there is no multi-platform IO yet. I mean, there kind of is. I could have chosen to use OKIO, but I just decided to write my own. Yeah, so...
that's, I guess, so this is the common one.
That's the expect, and you should be able to hit the A and jump to
actual. And we'll look for the JVM one.
Yep, which is going to try to load it from a directory if an environment variable is present. Otherwise, it'll load from resources. I set up the Gradle build script to dump them into resources as well. So in theory, the jar that gets built by this is portable and runs on its own.
Oh, that's nice. That's elegant. And then the other one is the native one.
Native doesn't really have resources, so this is using...
Okay. Yeah, do tell.
Yeah. So, it would be nice if this was easier in the future, but for now, this is what it is.
Okay, all right. So, I have to admit, I'm not a Kotlin native person.
I mean, this is basically the same as programming in straight C, just with different syntax.
And with a little bit of funky stuff around. Okay, so here we're starting with, I guess, like syscalls.
Yep.
And then file descriptors, addresses, buffers. That sounds fun. Yeah, I can see why there's a necessity for a library abstraction here, because if I want to load a file, I don't want to spend the equivalent of like one Advent of Code puzzles worth of code.
Yep. That, not just that, but it's unsafe. You can easily crash by writing out of bounds of your buffers and so on in here as well. So there does exist OKIO, which does have a cross-platform file system component. I just didn't want to add a dependency.
That's, I think, from Square, if I got that
one
right. Yeah.
Yeah.
So this is the library, a modern IO library for Android, Java, and Kotlin multi-platform. Look at that. Yeah, and I think
of version 4 or 5, I don't remember, something like that.
Oh, nice. Now let's see here. I'm not sure where they have their version. This is a very short short readme.
Yep.
And I'm still not seeing any version numbers. 3.x, maybe.
3.x, maybe. I don't remember the version numbers, but yeah, something like that. So I could have used that, but just made this anyways.
This way is standalone. I guess you got to dive a little bit into Kotlin native a little deeper. That's really cool.
Yep.
And the processor is also custom built, you said, right?
It is. So if it is right there in the processor folder, so you can
peek
see
in here. Okay. And here we've got, there we go. Now it's waking up. So just for context for people, again, this is a not Kerbal Space Program,
which is a great program. It's a great game, but it's not super helpful for Kotlin.
Certainly. Is Google's project for writing kind of lightweight compiler plugins. It's a bit of a simplified API, which is also faster than capt, which is or capt, which is the annotation processor we have in Kotlin for.
Wow. There's also the thing that because I'm writing multi-platform, capt is not available to me because it is tied to Java.
Okay, yeah. So instead, you are grabbing things like your day annotations, turning these, I guess, into doing a bunch of processing here, and then eventually somewhere emitting some code, I guess.
Yep, you see it right here.
Yeah.
Yep.
Kind of strewn across a couple of strings here. I guess this is where some people would also use Kotlin Poet or those kind of libraries.
Yep. I mean, this is Kotlin Poet that is being used to build the code. So
okay.
ASP is being used to read, the annotations and to hook up, having the output actually go to the compiler. And Kotlin Poet is being used here to actually generate the code that should be compiled.
Nice. Okay, yeah. Since I just peeked into this, I wasn't sure if these were custom ones or if these were Kotlin Poet implementations. Because I think at the end of the day, you just need to generate like a string of like source, right?
Exactly. Yeah. So, well, slightly more than that. So it's KSP's API asks you to basically also tell it what dependencies went into it so that it can do incremental recompilation.
I see. Okay. So everything you've looked at, you're also gonna deliver at the end. Okay. So I'm just gonna say what I'm thinking here. This is entirely unnecessary, and that's why I love it. Which is great, which is excellent. Was this just for pure experimentation or wanting to get to know KSP?
Yeah, well, so this is maybe the third or fourth KSP processor I've built, but I have used it in a couple of other projects, but nothing in production yet. So this is basically, helping me learn how to use KSP. And similarly, like, there's the Graal VM folder, which is set up so that I can build a actual native image. So there's the build script has some kind of nasty hacks to grab the jar from the parent build.
Okay.
Since I can't load the Graal VM plugin into the same build as the multi-platform plugin because it's not a Java project. So it's a bit tricky, but it's set up here so that, as long as you have Graal VM installed, it'll be able to basically build your program into a native program. And
without going through Kotlin native.
Exactly. It takes your JVM program and it actually has to instrument it first. That's the agent that you see here in the build script. So it runs the JVM program once with an agent that is basically saying, okay, here's everything that I'm accessing reflectively, or here are all the resources I'm accessing, or so on, because those can't be discovered during static compilation.
Okay.
And then using that to feed back into its compilation process.
So the agent in this case helps you avoid having to manually specify which calls are accessed reflectively, like, and I'm gonna speculate here, like you would have to do with stuff like R8 and those kind of precompilers?
Yeah.
Okay.
Yeah. So there's still some exceptions I have to put in here because reasons. But
of course.
Yeah.
So since you and you said you're benchmarking these ones as well, right? So where kind of just on a super high level across like the problems that you've solved in Advent of Code, where are the different platforms falling? Where's JVM falling? Where's Kotlin native falling? Where's Graal VM falling?
So you can actually see if you go to my repository
On
GitHub.
one up. Okay, yeah, sorry. Yeah, well, this one, yeah.
Yep. Up, scroll up, and up, further up, all the way up. So up on the right where it says .github.io, click that. And then click kotlinlex.benchmark. And so this is not a very good view, but if you see the blue summary button, tap that. And that basically shows, so in operations per second, JVM did 24K, and the Graal VM compiled native image did, what is that, like 5 point something K? And
yeah,
Kotlin native did much less.
0 operations. Okay.
So,
this says it's 4.
yeah.
Okay. Interesting. Very interesting to realize that this shows that JVMs is fast.
Yeah, well, so part of this is that the way the benchmark works doesn't show the JVM's weaknesses, right? This is rerunning the same function repeatedly. So it is definitely warm. We're not counting warm-up time.
Yeah.
The garbage collection time is just averaged out across everything. So it is basically the ideal case for the JVM.
Understood. Okay.
Right. So
yeah.
Graal VM native image is, in theory, right, it should be able to do as well. It's just not there yet. And Kotlin native is also like, it should be able to do better. It's just not there yet. There's a lot of different parts. I can understand there's a lot of different parts in Kotlin native that need attention right now. And so performance is not the number one priority, right? You have to make sure it actually works right first.
Yeah. Right. But at the very least, we're seeing somewhat consistent results here. So that we can make some kind of statement, I suppose. Again, with these measurements, we're seeing the JVM very up high, followed by Graal, and then Kotlin native also somewhere. Okay, interesting. That's really cool. I'm very glad that there's no Rust in this comparison.
I mean, I do have benchmarks for Rust and actually all the languages I'm using, but they're not in the same format. So
phew.
Can't be easily compared.
Yeah. Lucky us, I suppose.
Well, JVM is actually within a good, I would say on most days I'm within 2x of Rust.
Okay. That's much better than I thought. Honestly, that's
there's a lot of magic that goes into the JIT. That it's surprisingly amazing.
Oh yeah, absolutely. So before we wrap up for today, I did want to ask you this question, which is, as someone with hobbies kind of like Eric's, what do you think are we gonna see for the next couple of days?
So it's kind of tough to say what's coming up right away, because it's like there's just a couple of themes that he loves to revisit, like, simulations and RPGs and, as we mentioned before, virtual machines and mazes are something that have not come up every year, I think, but most years have come up at least once. So some sort of path search. So for the coming week, I think, given that, day 7 happened and this was probably the hardest problem so far, I think it's probably going to be at least this level, but what will he choose to do things with? I don't know. I am kind of hoping for a good sort of, sometimes he has problems that are like, it's a simulation problem you can solve with just like straight simulation, following the rules exactly as they're described. And sometimes there's a neat mathematical shortcut you can find in them, right? Like there was one a few years ago that was basically literally just the, what is it called, Josephus problem.
Okay.
So that is what I am looking forward to in the coming week. We'll probably see, because it's the ones on like day 20 are probably going to be too hard for super easy shortcuts, but that's what I'm hoping to see in the next week or so.
Okay. Well, it sounds like maybe if I find a free minute, I need to study up. I'll be honest with you. I think my weak point here is if an actual Dijkstra or Bellman Ford, those give me a little bit of trouble. So I need to study up.
Well, I mean, it does seem like if you can write a depth first search and a breadth first search, you are pretty good for most Advent of Code problems that require, two searches.
I have flashbacks. I have flashbacks from I think one or two puzzles where I'm like, please.
Yep. No, like it is. I have written more A-star searches for Advent of Code than I've done for any school projects or anything ever.
Okay, wow. That's I think that says something.
Yep.
Oh my. Well, Efemian, thank you so much for joining today. This was really, really lovely. It was really cool getting all these impressions.
Yeah, great chatting with you. And I think I'm looking at the chat comments on the side. I think they've been having fun with the problems as well. So
yeah, I think everyone has kind of had an enjoyable time. And speaking of enjoyable, I do want to announce that due to popular request, we're gonna extend the streams. We're not gonna extend them all the way, but we're gonna extend them a little bit. So my little Advent gift to all of you is we're gonna do 2 more streams. We're gonna cover day 11 and day 12 as well. It's gonna be the last day before my Christmas vacation, so unfortunately longer than that's not gonna happen. But we're gonna have 2 wonderful guests for those streams. It's gonna be our resident person who always wants harder problems. It's gonna be Olaf, who also contributed one of the visualizations we saw yesterday. And the other person is gonna be Dave Leeds, who, if you've ever seen any of his comics or cartoons on Kotlin, then you might recognize him as well. And he's gonna join us for one of those 2 days as well. So it's gonna be really exciting. Tomorrow is, of course, one of the real special days, because we got our big guest Roman Elizarov coming. If I don't have my own calendar wrong, I'm just gonna double check that one. Yeah, look at that, it's Roman. And yeah, I of course hope to see a lot of you for that tomorrow, and I of course hope to see a lot of you for all the rest of the days, now that I've decided I would sacrifice myself for another stream. No, I'm having a great time here as well. It's really good. Okay, wonderful. Then I hope to see all of you in tomorrow's stream, and I'm wishing you a wonderful day, evening, or night, wherever you are. Take care. Absolutely. And good luck tomorrow.
Happy Advent.